Okay, so good day everyone. My name is Arlvin Eberkala, and here again in this video, we are tasked to find the value of x, y, and z using the Cramer's rule. So we have here our given equations. We have 7x plus 6y plus 3z is equal to 1, and negative 2x plus y plus 4z is equal to negative 1, 11x plus 8y plus 9z is equal to 3. So we write down all the coefficients in matrix form. So 7, 6, 3, negative 2, 1, and 4, 8, 11, 8, and 9, and separate the constant using a vertical bar, which are these values. So 1, negative 1, and 3. So the first thing we need to do in finding the values of x and y and z using Cramer's rule is to first find the determinant of the square matrix or the matrix for x, y, and z. So we find the determinant of this 7, 6, 3, negative 2, 1, 4, 11, 8, 9 using net method. So we multiply it diagonally. So 7 times 1 times 9 is equal to 63. 6 times 4 times 11 is equal to 264. And 3 negative 2 times 8 is equal to negative 48. Minus the other diagonals, we have 11, 1, 3, 33, 8, 4, 7, 2, 2, 4, plus 9, negative 2, 6, negative 108. Simplify. 279 minus 149 is equal to 130. So the determinant of this square matrix is 130. So now, in finding the value of x, we just have to simply replace the values of x with the constants in then find the determinant of the matrix. So here in our case, we have the values for our x 7, negative 2, 11, and the values of our constant 1, negative 1, and 3. So since we are finding the x values first, we replace these values by the constants. So our x values now will be 1, negative 1, and 3. Then just copy the other values, 6, 1, 8, 3, 4, 9. Then find the determinant of the square matrix using the net method also. So 1 times 1 times 9 is equal to 9. 6 times 4 times 3 is equal to 72. And 3 negative 1 times 8 is equal to 24. And the other diagonal minus the other diagonal, 3 times 1 times 3 is equal to 9. And 8 times 4 times 1 is equal to 32. And 9 times negative 1 times 6 is equal to negative 54. Simplify. 57 minus negative 13. So the determinant of our dx is equal to 70. Then we proceed first through the values of y. So same as true on what we did with the values of x. We will substitute, or no, we will just replace the values this time of y by the constant. So just copy the remaining coefficients. Copy 7 to 11, 7 negative to 11. Then replace these values by the constants. So our y now will be 1, negative 1, and 3. Copy the values for z. 3, 4, or the coefficients of z. 3, 4, 9. Then find the determinants by using again the net method. 7 times negative 1 times 9 is equal to negative 63. And 1 times 4 times 11 is equal to 44. And 3 times negative 2 times 3 is equal to negative 18. Minus the other diagonal, 11 times negative 1 times 3 is equal to negative 33. 3 times 4 times 7 is equal to 84, and 9 times 2 times 1 is equal to negative 18. Simplify. Negative 37 minus 33 is equal to negative 70. So our dy is negative 70. Then we proceed to the values, to the coefficients of z. Same as true as what we did the other two x and y. Just replace the values, the coefficients of z by the constants. So we copy 7 negative to 11, 7 negative to 11, 618, 618, and then replace the values of z by the constants. Negative 1, negative 1, and 3. Then find the determinant of our dz by using again the net method. So 7 times 1 times 11, 7 times 1 times 3 is equal to 21, 3 times negative 1 times 11 is negative 66, 6 times negative 1 times 11 is negative 66, 1 times negative 2 times 8 is equal to negative 16, minus the diagonal 11 times 1 times 1 is equal to 11, 8 times negative 1 times 7 is equal to negative 56, and 3 times negative 2 times 6 is equal to negative 36. Simplify negative 61 minus negative 81. So the value or the determinant of our dz is equal to 20. So now in finding the value of our x, y, and z, we use this formula for finding the values of x. We have the determinant of x or dx over the determinant of the original matrix. So the value of our dx is 130. No, 70. The value of our dx is 70 over the value of our the determinant is 130. 70 over 130 is equal to 7 over 13. Now proceed to the value of y. dy over dy. Value of dy is negative 70 over 130. 30 is equal to negative 7 over 13. The value of our z, we use dz over d. The value of dz is 20 over the value of the determinant of the original matrix 130 is equal to 2 over 13. So now we have the values for our x, 7 over 13 is equal to negative 77 over 13, and value of z 2, 13. So to check, if we try to substitute the values of x in our equations, in either of these equations, the statement or the equation will be always so. And that's it. Thank you. Bang Bing.